Hello there, welcome to A-Level Maths Applied June 2023. Here we're on the final mechanics question 6. A rod AB has mass m and length 2a. The rod has its end A on a rough horizontal ground and its end B against a smooth vertical wall. The rod makes an angle theta to the ground as shown in figure 3. The rod is in rest and limiting equilibrium. State the direction, left or right, in figure 3 above, of the frictional force acting on the rod A. Give a reason for your answer. Well, it's going to be acting to the right because this is the direction the rod will slip. Because the direction the rod will slip is to the left. So it would slip to the left, so therefore friction is acting to the right. Okay, so there we are. Let's move on to part B now. The magnitude of the normal reaction of the wall on the rod is S. Okay, let's add that onto the diagram. In the initial model, the rod is modelled as being uniform. Use the initial model to answer part B, C, and D. By taking moments about A, show that S is equal to half mg cot theta. Okay, well let's first of all add some detail to the diagram. We know that its mass is m, and we've got an angle alpha. We also know the distance is 2a for the whole ladder, so it's divided into an A and an A. We need to resolve the component of the mg force, that's mg cos alpha. And now we can now we need to resolve the moment of S. So resolve the direction of S so it's perpendicular to the ladder. We'll have alpha here, so therefore it's theta there, 90 minus theta there, and we want the cos component of 90 minus theta, and 90 minus theta is sine, so it's S sine theta. I should meant to use theta there as well. So moving on to part B then. So taking moments about A, so this mg cos theta moment is going to balance out this S sine theta moment. So mg cos theta times A will balance out the moment with S sine theta times 2a. Okay, so let's divide the sine and the 2a onto the other side, and that gives us mg cos theta times a, all divided by sine theta times 2a is s. Now if we simplify the cos over sine, we get cot. The a's cancel, and then we've got the half at the front, so it's half mg cot theta is s. Excellent, so there we are, that's proved part B. The coefficient of friction between the rod and the ground is mu. Given that tan theta is 3/4, find the value of mu. Okay, so our other strategies relating to ladders is upwards forces equal downwards forces, leftwards forces equal rightwards forces. Okay, so we've got friction there, we've got reaction force here, so therefore if we look at the whole model and resolve our forces upwards and downwards, so now ignoring all of these component forces, just the main forces, R is equal to mg, and if we resolve our forces left to right, friction is going to equal S. Okay, so we're now going to use F equals mu R. So friction was S, and that's equal to mu times mg. Now S was half mg cot theta equals mu mg. If tan theta is 3/4, then cot theta is 4 over 3, so it's going to be half. We can cancel out the m's on both sides and the g's on both sides, times 4 over 3 equals mu. Multiply those two things together, and 2/3 is our answer for mu. Excellent, there we are. Okay, let's now move on to part D. Find, in terms of M and G, the magnitude of the resultant force acting on A on the rod. Okay, so we had the reaction force there and the friction force here. So the reaction force was equal to mg from earlier, and the friction force is equal to mu r, so that would be 2/3 mg. Now the magnitude of the resultant force means to take both of those forces and do a bit of Pythagoras on that. So the square root of r squared plus f squared is going to be mg all squared, add 2/3 mg all squared. We can pull out a factor of mg squared square rooted, so that's 1 plus 2/3 squared, and let's do that on the calculator. Square root of 1 plus 4 over 9 gives us root 13 over 3 mg, and there we are, that's the answer for part D. A new value for S is calculated using the model with tan theta equals 3 over 4. State whether this new value of S is also we need to read this sentence here. In the new model, the rod is modelled as being non-uniform, where its centre of mass is closer to B. Okay, so it's closer to B, it's more like up here. A new value of S is calculated with the model with tan theta 3 over 4. State whether the value of S is larger, smaller, or equal to S, given the smaller, larger, or equal to the value of S would take from the initial model. Okay, that's a good question here. So we've got S here, we've got a new mg over here. It's now going to be Ka, and this is going to be 2 minus Ka. So if we now do exactly the same thing that we did in part A by taking moments about A, then we're going to get mg cos theta times Ka equals S times sine theta times 2a. Divide that to the other side and we're going to get 1 over 2k mg cot theta equals S. And now if k is bigger than 1, then S, if we put a dash on here, so the new S is bigger than S. So therefore, S is now bigger than the original value of S. There we are, so that's the answer for question 6 worth a total of 13 marks, and well, thank you very much for watching this series of videos. Best of luck with the June 2024 set of papers now, and if you're listening to this a little bit later than that, then head over to the June 2024 papers. Thanks for watching. Hopefully you found this set of videos helpful.